Let's use rotation to figure out conic sections and to be able to graph rotated conic sections. So if we have a general form of equation that looks like this, we can complete the square twice to put the equation in standard form. And we would use the x squared and the dx. We would use the cy squared and the ey to figure out what to add for y. And then once we have that, we'd have something with x squared, we'd have something with y squared, and then on the other side of the equation we'd have some sort of number, and then we'd divide by that number to get something like what we're used to. So plus or minus there, and we would have some sort of conic section, depending, it might be a circle, ellipse, hyperbola. But you'll notice that I skipped over something between ax squared and cy squared. This assumes that there's another term in here missing, and that missing term is if we have an x times y term. And that's what we have here. If we have it being plus bxy, where b is not 0, then we must first rotate the axes before we can complete the square. We can't complete the square with xy. So we have to rotate the axes in order to get rid of xy first. So the angle that we're going to want to rotate by is given by a minus c over b equals cotangent of 2 theta. So we can figure out what a is, what c is, what b is, and then use this equation to figure out what angle we need to rotate by and then perform the rotation. So first I'm going to just ask what angle of rotation should we use. Well, a is -3, b is the coefficient here, -2 squared is 3, and c is -1, d is -1, e is square root of 3, f is 0, but we don't need those. We need -3 minus -1 over -2 squared root of 3 equals cotangent of 2 theta. We subtract the numerator, divide, and we get 1 over square root of 3, cotangent of 2 theta. If you don't know what that is off the top of your head, you can certainly use the reciprocal identity to say that this is square root of 3 equals tangent of 2 theta. And therefore, we're looking at 60 degrees plus 180n equals 2 theta, which is not to say we should use 60 degrees. We should divide by 2 first. 30 degrees plus 90n. So typically we'll rotate by 30 degrees, but if you chose to rotate by 120 or 180, or by 120 or 210, that would also work. So we would rotate by 30 degrees there. Here, let's see what we would rotate by. A is 41. B is -18, C is also 41. So we would rotate by A minus C over B equals cotangent of 2 theta. So we have 0 equals cotangent of 2 theta. Cotangent is 0 at, say, 90 degrees. So 90 degrees equals 2 theta plus 180n. So we can divide by that by 2 and get 45 degrees, or we could use some multiple of it. So we would probably rotate by 45 degrees. So now let's do an actual rotation. Let's rotate these axes and graph. So A is 1, B is 2 square roots of 3, C is -1, so we can say 1 minus -1 over 2 square roots of 3 equals cotangent of 2 theta. So 2 over 2 square roots of 3 equals cotangent of 2 theta. And 1 over square root of 3 equals cotangent of 2 theta. So because of that, we will want to rotate by, well, square root of 3 equals tangent of 2 theta. So this is the same as the previous, this case that we had, where we're going to be using 60 plus 180n. So we want to rotate by 30 degrees, or add 90 to it, but we definitely want to just use 30 degrees. So now that I've found out how much I'm rotating by, I'm going to move this to the side. Woo! And we need to figure out if we're rotating by 30 degrees, what's going to happen? Well, we're going to say x was x prime times cosine of 30 minus y prime times sine of 30. Y equals x prime sine of 30 plus y prime cosine of 30. So that means that x is going to be x prime squared to 3 over 2 minus y prime over 2. Y will be x prime over 2 plus y prime squared to 3 over 2. And now we have to substitute in. Alright, so the substitution is going to take a little while. I'm going to actually just copy this over, create a new page with this information on it, delete all the things we don't need for now, and begin. So x squared is x prime squared 3 over 2 minus y prime over 2 squared. We have 2 squared 3. We have this x prime squared 3 over 2 minus y prime over 2 times, well, what's y? X prime over 2 plus y prime squared 3 over 2 minus y squared equals 50. So taking this, putting that aside, we see that there's a 1/2 squared, so 1/4 is a coefficient. We have x prime squared 3 minus y prime squared. We see, again, 1/4 is a coefficient, so we have a square root of 3 over 2. And that's x prime squared 3 minus y prime. Again, I'm factoring out a 1/2 out of each of these. Here we have 1/4 and x prime plus y prime squared 3 squared. That all equals 50. So if we multiply by 4 on both sides, we get x prime squared 3 minus y prime squared plus 2 squared 3 x prime squared 3 minus y prime, x prime plus y prime squared 3 minus x prime plus y prime squared 3 squared equals multiplied by 4, so 200. Let's start multiplying things out. X prime squared is x prime squared. Square root of 3 squared is 3. Now we're going to do negative 2 square root of 3 times x prime y prime. And then we do y prime squared. 2 square root of 3 times, well, this is x prime squared times square root of 3. We have x prime square root of 3 times y prime square root of 3 is 3 x prime y prime. We have x prime times negative y prime, negative x prime y prime. Negative y prime times y prime square root of 3, so minus y prime squared square root of 3, minus, we have x prime squared plus 2 square root of 3 x prime y prime plus y prime squared equals 200. Getting close. The first piece is all set. Distribute this in. So we get 6 x prime squared plus 6 square root of 3. Oh, let's combine these. If we combine these, we get 2. So 2 times 2 square root of 3 is 4 square root of 3, x prime y prime, minus 2 times square root of 3 times square root of 3 is 6, y prime squared. We're distributing in a negative, x prime squared minus 2 square root of 3, x prime y prime minus y prime squared equals 200. We have 3x prime squared, 6x prime squared, and negative. So 3 plus 6 is 9, minus 1 is 8 x prime squared. We have negative 2 square roots of 3, positive 4 square roots of 3, negative 2 square roots of 3. Good, those add to 0. That was what we needed. If those don't add to 0, we did something wrong. Y prime squared, negative 6 y prime squared, and negative y prime squared. These two add to 0, so we have negative 6 y prime squared equals 200. Now we can divide both sides by 200. So we have 8 x prime squared minus 6 over 200 y prime squared equals 1. 8 goes into 200, let's see. 1, 2, 4, 25 times. And now this 6 goes in, well, 2 goes in once, so this is 100 thirds y prime squared equals 1. All right, now that we have this, we can graph. Yes, we can graph, and oh, wait a second, there was an error here. This cube, this square root of 3 squared should give us a 3 there, which means that's a 3. Negative 6 minus 3 is negative 9, plus that is negative 8. That makes more sense. Okay, so this should also be 8. And this should be 25. So now we have a hyperbola. It's a hyperbola because of the negative. We have the we have A is 5. We have B is 5. And C is going to be square root of 50, which is 5 square roots of 2. So first, we want to describe what our 30-degree rotated axis is. So a 30-degree rotated axis looks like that approximately. We should get about there. There's 30 degrees approximately. Now that we have rotated our axes, we can set our center to be the 0, 0. We can go 5 along this axis, 5 along this axis, 5 along this axis, and 5 along this axis. And now, using that, we can create our asymptotes. And from those two things, we can set up that this is going to be our hyperbola. It is rotated, and we had to rotate that in order to figure out the graph. Thanks.